Okay, today is a new section. Just a little bit. Section 4. Okay, we have two new methods. Right? What we did on the previous section, side, 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 and side, angle, side, each required at least two pair of corresponding congruent sides. Today's deal with the same thing, only dealing with angles. Okay, your materials for you to look over outside of this video. The notes, chapter 4, section 4, that's the PowerPoint presentation in files, okay, also in files. The notes I've provided, chapter 4 notes, pages 13 to 16, go over just these two, okay? I'm going to tell you right now that there is no way we deal with an angle, angle, angle. Think about it. Every triangle that's ever been drawn has 180 degrees in it, okay? So if I have a triangle here with each of those being 60 degrees and a triangle there with each of them being 60 degrees, there's no way those are congruent triangles. They're not the same side. So what you need is at least one pair of congruent sides. It reels the angles in, so to speak. Okay, here we go. The first one for the day is angle, side, angle. Yes, the side has to be located between the congruent angles. Otherwise, it's not this method, and we have to look for another one. Okay? We prove that two pair of corresponding angles are congruent, and the side included between them, then you have congruent triangles. Here are examples. Pair of congruent angles, pair of congruent angles, side that is in between them. ASA. Same thing up here. There's a pair of congruent angles. We're using vertical angles here. There's the sides with the other angles. Once again, in between the congruent sides. Angle, then the side, then the other angle. The other one for the day is angle, angle, side. Excuse me. Okay? Now in this one, the pair of sides can't be the one in between. So we've taken care of both opportunities, where the side is between the congruent angles and where it's not. Okay? And prove the two pair of corresponding angles are congruent and a pair of corresponding sides that are not included, then the triangles are congruent. I've got three examples up here for you. There's a pair of angles, side not in between. Once again, congruent angles, side that's not between them. Okay? Yes, you're dealing with vertical angles a fair amount. Okay? You're also going to deal with parallels here. Okay? Angles, and a side that's not between. Yes, it has to be the same side corresponding on each triangle. Okay? Let's go to the work that's going to illustrate these today. Okay? Our first is some triangles. Yes, we'll get a few of these today as part of the assignment. I'll get you a little closer there. So what we're going to do is name which of our methods we can use to prove congruency. Well, in each of these I've given two pair of angles, pair of sides, something like that. So let's look at it and see what we've got. On the first one, okay, we have a pair of congruent angles, and there's a pair of sides. What we can prove, vertical angles are equal. Okay? Vertical angles is the pair of sides that are congruent between those angles. No, they're not. So what we're dealing with here is angle, angle, side. Okay, we move down here. Yep, I've got another pair of vertical angles. Okay, so we're just going to mark it right now. Okay, so let's look at what we've got. A pair of corresponding congruent angles. Sides, corresponding and equal, another pair of angles. Angle, then the side, then the angle. Okay? Now we're going to move over here. And I'll pick this up. Gotta love gravity. Okay? Here, I have a pair of angles and another pair of angles already given to us. What we can prove is that this side, which is part of each triangle, has to be equal on both triangles. Okay? That's going to be reflexive property. I've got a pair of angles, then a side that is not between them. Okay? Over here, pair of congruent angles. Another pair of congruent angles. Okay? In this one, we've got another shared side. So we've got angle, angle, side. Okay? Let's take all of these lovely colors and head over to here. I've got two proofs for you today. One illustrating each, okay? And as I explained on your last lecture, you're going to be able to use different methods for the same triangles depending on what information you're given. Okay, let me get you closer. There we go. That's better. Okay, on this, the given information is that S is the midpoint of QT. If something is a midpoint, that means we have two equal parts. So that means that QS and TS are equal to each other. That's that one right there. Okay? Then, QR and TU are parallel. Parallel lines give us alternate interior angles that are equal. Okay? For this particular example, I'm going to use these. Okay? Yes, for those of you paying attention, I could also say that these two were equal to each other, and I'd be done with angle, angle, side. Okay? This is the beauty of geometry. There's not just one way to do many things. Okay? There's going to be multiple ways to solve the problem. Okay? This is just one of those. Our next situation, we've got our vertical angles. Okay? And there we have it. Pair of angles, pair of sides, pair of angles. ASA. So, we'll start out. Okay? So let's start out with our given information in this case. And it doesn't matter which one you do. Okay? Now, I started with the top. So I said, I'm also going to stay with this because I'm going to write down what that allows us to say. Okay? Okay? That's the definition of a midpoint. Okay, now we're going to use the other givens. Okay, the parallels. And then what this allows us to say. Okay. Then we said we had the vertical angles. Okay, and our last one, because they are congruent now, we've shown everything, okay, that we need to show. To be honest with you, we prove it up here. We just write what we did down here. Because once you understand the marks that go there and why they go there, you understand the proof. This is secondary, to be honest with you. Okay? Okay? Let's move over to our next. This one that looks like a rocket ship. Here we go. Okay, D is congruent to F. Those two are given to us as equal. We'll go with this. Okay. Then we've got GE bisects DEF. If you've got an angle that's bisected, you've got equal angles. So these are our second congruent angles. Okay? Our last one, we've got corresponding sides. So I have a pair of angles, a pair of angles, a pair of sides. The triangles are now congruent with AAS. The side is not between the two angles. Here we go. Okay. I'm going to put the two givens together on this one. Only I'm going to do it the right way. Okay. Okay, so those are my two givens that are put together. Now I'm going to list here what this allowed us to say up there? Okay, if we have a bisected angle, that means we have two equal angles. We list them here. Yes, abbreviating. So definition of an angle bisected. Okay, now we put our sides up. Okay, and our last one, now that we're done basically, is the triangles are indeed congruent. Okay, there we have it. Okay, yes, I make this look kind of easy. I've done it for a long time. Some of you are going to catch on and get comfortable with this. Some of you never will. I understand that. Okay? Doesn't mean anything about you as a human being. It just means that you just don't see any value in this, and it is difficult. I'm not going to lie to you. Okay? You have to deal with knowing your terms. What I'm really worried about, and I'm really concerned, and I want you to get, is to be able to do this. What does the given information allow you to say? What is it you can prove to be congruent? And then say, oh yeah, those are congruent because of this. If you never get this part in here to write it down, I'm going to have to live with that. Okay? But this you're going to get. Okay? Trust me, you will. Okay. We are good.